All right, so we're getting into 7.3, and this is where we actually start using some trigonometric equation or trigonometric functions in equations and inequalities. And remember, a function is a function is a function. Just as easily as we can put the square root of x in an equation or an inequality, we can do the same thing with trigonometric equations. And we can solve them doing the same exact thing. And that's what we're going to look at during this this section. All right, now inverse operations can be used to solve trigonometric equations and inequalities, but the number of solutions needs to be carefully analyzed. The unit circle gives infinite solutions. These will need to be restricted based on the interval given or the context. Evaluating inverse trig functions on the calculator gives only one solution. There may be more outside of the ranges of arcsine, arccosine, arctangent. So if you go and work backwards, remember, if you use this, if you use any of the inverse trig functions to find the solution, but those are not actually in the equation itself or the inequality, you're only going to get one. Then you have to figure out where the other ones are and how they come from, where they come from. So you're going to find those using the symmetry of the unit circle. And this is going to make more sense. It's kind of like when you take the square root and you have to end up putting the plus or minus out there when you introduce the square root like we've talked about. This is the same thing. You're going to use arcsine to find one, but arcsine is not in the equation. You did the arcsine. So, but you're looking for all the angles that would give the same value to plug into that equation. So unless it's got limitations, and even when it's got limitations, you still got to check. I promise, this is going to make a little more sense when we actually get to a problem. So let's go ahead. All right, so number one, solve 2 cosine theta minus 5 equals negative 7 for theta between 0 and 2 pi. All right, so while this may look really confusing, here's all you're going to do. You're going to treat that right there for now like a variable. Treat it like x. So you literally have 2x minus 5 equals negative 7. The only time that you're going to treat this thing any differently is once you have it isolated. So now, first things first, we're going to add 5. Plus 5 plus 5. We got 2 cosine theta is equal to negative 7 plus 5 gives me negative 2. And then, same thing, we're still going to treat that cosine x as just, or sorry, cosine theta as an x. So we're going to divide by 2, divide by 2. So cosine theta is equal to negative 1. So now, this is where you would use the inverse trig function. So we're going to take the inverse cosine of cosine theta and the inverse cosine of negative 1. And guys, you can do this in your head, but the inverse cosine of cosine is going to give us theta. And we're looking for where on the unit circle, and remember with the inverse cosine, we're looking from 0 to pi. Where on 0 to pi is the cosine value going to be negative 1? Well, that's going to be at pi. Now, then what you've got to do is you've got to look and you got to think, is there anywhere else on the unit circle from 0 to 2 pi where that value is going to be equal to the cosine value? Are you ever going to going to find a cosine value of negative 1 anywhere else on the unit circle other than at pi? And in this case, no. So that is the only solution there is between 0 and 2 pi. Now, here's the thing. What if they had said from 0 to 4 pi? Well, for 0 to 4 pi, you would have theta equals pi and 3 pi, because it's negative 1 at 3 pi as well. They didn't, so we're only going to do from 0 to pi. But understand, if they give you a larger domain, for your, or a larger range for your answers, you've got to, well actually that is the domain, isn't it? They give you a larger domain for the answers. You've got to look at all those places where that's going to give you the correct answer. So now you can always go back and plug in and check too. If I plug in pi right here, I'm going to evaluate cosine pi. Cosine pi. Cosine pi is going to be -1. And then 2 times -1 gives me -2. -2 minus 5 does give me -7. Check. All right. So for this one, we're going to find all the solutions where sine theta equals 0.75 for 0 to 2 pi. Now, if that doesn't kind of give you a hint that this is a calculator problem, I'm going to tell you it's a calculator problem because 0.75 is not on the unit circle. So you've got to find what angle is going to give us a sine value of 0.5. So what that means is we're going to take the inverse sine of both sides. So you're going to have to do that with your calculator. All right, so when I use my calculator to find the inverse sine of 0.75, I'm going to get approximately 0.84806. All right, now remember what we've just gotten. Inverse sine of sine theta is going to give us theta. We take the inverse sine of this, so that is my angle. So then we need to think about where we are and what we've got. So the sine that's positive is only going to happen in quadrants 1 and 2. So those two right there, because remember sine is my y value. And this number right here is going to be in quadrant 1. Now why do I know that? Well, I know that because remember the whole purpose of the inverse sine is it's going to give you an angle between -pi/2 and pi/2. So any angle that comes out of the calculator when you do inverse sine is going to be an angle in this blue area here in quadrants 1 or 4. This one happens to be over here in quadrant 4 somewhere, or quadrant 1 somewhere. But we're looking for all the values on 0 to 2 pi where we have a sine value that is a positive 0.75. Sine is positive once again in quadrant 1 and quadrant 2. So we need to find in quadrant 2 where we're going to have a sine value that is 0.75. So here is what we need to do. If this angle right here, if that angle right there is 0.84806 radians, we need to find an angle over here that matches it so that that y value is exactly the same. Well, remember, the key thing is to measure from the closest x-axis up. So if this is 0.84806, then we want this angle right here also to be 0.84806. So how do we find the angle that we're really looking for, which is this angle right here? Well, it's actually really, really easy. If we take the entire angle all the way over here to pi, and we take this amount away, then that's going to give us this angle, that's the green. So to find the other one, we want to do pi minus 0.84806. So we can punch that in our calculator, literally put pi, the symbol, minus, and then second negative to put the A and S in, the previous answer, and you're going to get that that is 2.2935. So those are the two angles on the interval from 0 to 2 pi that if you were to plug that in and find the sine of those angles, you're going to get 0.75. Now you can even check it with your calculator. You've already got the answer right there, so just do sine of second negative, and that's going to put in the previous answer that we just found of 2.29. Close your parentheses, hit enter, and boom, 0.75. All right, so just to make sure that you're getting it, hang on just a second. All right, so just to show you real quick on the calculator what we did there, remember we found the inverse sine, so second sine of 0.75, enter. That gave us the 0.84806. So remember, that is the angle, the only angle in the domain of the inverse sine, in other words, from negative pi, or the range of negative sine. So negative pi over 2 to pi over 2, that's going to give us a sine value of 0.75. Now, we're looking for every one of them on the interval from 0 to 2 pi. So that's where we figured out that we needed to go over into quadrant 2. And to do that, we can simply say, to find an angle in quadrant 2 that matches an angle in quadrant 1 that we know, we're just going to do pi and then minus that angle. Now, to put that angle that we've got right here back in, all we need to do is second negative, and it's going to put the A and S in there. That means you're just putting the last answer in to calculate. So then we can hit enter, and our second angle on the interval from 0 to 2 pi, that's going to give us a sine value of 0.75, is 2.293530575. Now, if we wanted to check it, watch this. Sine of, once again, my previous answer, and that means I'm putting this number in now, enter, and it's going to give me 0.75. So this angle or this angle in radians will give me a sine value of positive 0.75. And that's what we're looking for. All right, so let's find all the x-intercepts of f of x equals 4 sine squared x minus 3 on the interval from 0 to 2 pi. So remember, an x-intercept is going to be where x equals whatever, but y always equals 0. If it's going to cross that x-axis, the y value has to be 0. What's another way of saying 0 or saying y? F of x. So we've got y equals 4 sine squared x minus 3, and then all we need to do is 0 is equal to 4 sine squared x minus 3. And then what you can do is you can solve this. This would maybe not be a calculator problem. Let's see. It doesn't look like it's going to be, just to be honest with you. So we're going to add 3 to both sides. Plus 3 plus 3. So we end up with 3 is equal to 4 sine squared x. And then we're going to divide both sides by 4. So we get 3/4 is equal to sine squared x. All right, so now we've got to get sine squared x to be a single sine x. And that's all that is that's the sine x times sine x. It is sine x squared. So we're going to take the square root of both sides. And when we do that, what are we going to get? Well, over here, we're going to get sine x. But over here, we're going to take the square root of the top, which is going to be square root of 3. and square root of the bottom, which is going to be 2, and don't forget, we just talked about this in the last problem. I hinted at it. Remember, if you take the square root in the process of solving the problem, you want to do plus or minus, not plus or 2. So plus or minus the square root of 3 over 2. So we're looking for all places where sine of x is going to be positive square root of 3 over 2 and negative square root of 3 over 2. So if we think about the unit circle, knowing sine, we're talking about if sine is positive, that's going to be in quadrants 1 and 2. If sine is negative, it's going to be in quadrants 3 and 4. So we're looking for literally all the places where we have either positive or negative square root of 3 over 2 as our sine value. Now, guys, one way that you can do this, you can completely get away from the inverse sine. Don't use your calculator on this. Just think about where on there it's going to be square root of 3 over 2. Well, sine is going to be square root of 3 over 2 if you use the little trick that I told you, where cosine of theta is equal to 1/2. Well, because these always come in pairs. And where is cosine theta equal to 1/2? Well, that's going to be all over the pi over 6's. So that means we're going to have a sine value that's the square root of 3 over 2 at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So our x values are going to be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Now, that is because I know the unit circle. And if you know the unit circle, this is going to be way, 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 way easier. You got to learn the unit circle if you haven't already, because you need to know it frontwards and backwards. And little tricks like this, that sine is square root of 3 over 2 is always going to be where the cosine is 1/2, and that 1/2, oh, sorry, I am wrong. That's over 3. I didn't even use my correct rule, did I? So it's going to be at all the pi over 3, so we're going to have pi over 3, 4 pi over 3, 3 pi over 3, no, hold on. Yeah, I'm having a brain fart here. So it's going to be at pi over 3, which is 2 pi over 6. It's going to be at 2 pi over 3, which is 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, which is 4 pi over 3. And then 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, but I want the 10 pi over 3, so that's going to be 5 pi over 3. So there are the actual answers, yeah. Had a brain fart there for a minute, I apologize. Cosines are going to be 1/2 where we've got the 3's on the bottom. And cosines are going to be over the 6's when we got square root of 3 over 2, because 1 plus 2 equals 3, square root of 3, or 3 times 2 equals 6. Yeah, my little memory tool failed me right then because I didn't think about it long enough. But yeah, there are all of our answers on the unit circle. One in quadrant 1, one in quadrant 2, one in quadrant 3, and one in quadrant 4, where we have those the value of square root of 3 over 2. The only thing that changes is the SIGN, whether it's a positive or negative. So for sine x, we got a positive, a negative, and a negative. All right, so let's go back to Patty. If you remember, Patty showed up in the last unit of, or the last section of the last unit, and she was riding a Ferris wheel. Same Ferris wheel, same amusement park, same problem. We're just going to ask something else. So in this case, how many minutes does the ride last? Well, remember, that was where we calculate the period. So the period is equal to the normal period. For cosine, it's 2 pi divided by b, whatever is multiplied times the variable inside the trig function, so it's going to be pi over 4. So keep, change, flip. 2 pi over 1 is equal to, times 4 over pi. Pi's are going to cancel out, and we're left with 8 minutes. All right, how many minutes does one ride last? Every ride is 3 full revolutions of the wheel. So that's the one thing that they've added here. So a period, 1 rotation, is 8 minutes. So the ride equals 3 revolutions times 8 minutes per revolution. So it's going to be 24 minutes. That is a long Ferris wheel ride. All right, and then they want you to find all times t at which Patty is exactly 40 feet above the ground. So now we're looking at negative 20 cosine pi t over 4 plus 23 and we're looking for where that is equal to 40. Now, with this one, it all depends on if this is a calculator problem or not. If this is a calculator problem, this becomes really, really, really simple, because all you're going to do is you're going to go in and you're going to graph this, and you're going to graph the line y equals 40, and you're going to see where they intersect and how many times they intersect. They're going to intersect a couple of times. They're actually going to intersect if they go around 3 times and 40 is not the highest point, then what do you know? Remember, 43 is the highest point on this thing. That means it's going to occur she's going to hit 40 feet twice every rotation. If she goes 3 rotations, you're looking at 6 values of t that you should be coming up with. So now, let's go ahead and see what we can do with this by hand. So first thing we're going to do is we're going to subtract 23. So negative 20 cosine pi t over 4 is equal to 17. All right, so then we're going to divide each side by negative 20. So we end up with cosine pi t over 4 is equal to negative 17 over 20. All right, so at this point we probably want to use the inverse trig function. So we're going to take the inverse cosine of both sides. Now, when we do that, the inverse cosine is going to knock out the cosine here. Those are going to cancel out and leave me with pi t over 4 equals whatever I'm going to get over here. I'm going to punch that in my calculator here. I'm going to do inverse cosine of negative 17 divided by 20, close parentheses, and that's going to give me 2.58678. Now, to keep this easy, we're going to go ahead and round this thing to 3 decimal places. So 587, and that's going to be what pi t over 4 is. Well, we're looking for t. We're not looking for pi t over 4. So we're going to multiply both sides by 4, divide both sides by pi. So that means that t (2.587 times 4 divided by pi) is going to give me 3.294. All right, so there is one time. There's time 1. But remember, we talked about the fact that there's going to be 4 different times. Here's where you're going to run into problems. If you go and you try to take this t and you're going to add to it, you're going to run into problems. So what we really need to find is we need to find where the other place where pi t over 4 is going to give us the exact same cosine value. So we kind of need to figure out where that is on the unit circle. So if we think about the unit circle, because we need exactly the same value out of it twice. So if we think about 2.587, remember this is pi over 2, so that is 3.1415926 divided by 2, so that's roughly 1.57. We've talked about this already. And then this is going to be 3.14, and then this is going to be 3.14 plus that, which gives you 4.71, and this is 6.28. So 2.587 is going to be in quadrant 2. So we're looking at an angle here somewhere. And we need to find a place where the x value is going to be exactly the same. Well, that's going to be right down here. If we've got an x value here, we need the exact same x value to come out here. Remember, cosine is the x value. So we need the same exact x value to come back out again. So we need to find what that value is. Well, if this value right here is 2.587, is that value, what is this value to go all the way around to there? Well, here's the thing. If we've got this, remember symmetry, this is going to be the exact same length as that one right there. It's going to be exactly the same angle. So what we need to do is go 2 pi, and we take away what we already found. So our other angle that we're looking for is pi t over 4 is equal to 2 pi minus 2.587. So once again, putting that in our calculator, we're going to have 2 times pi minus 2.587. And that's going to give us 3.696. All right, and once again, that's our pi t over 4. We've still got to go and solve for t. So let's find the t that corresponds to that one. So this will be t2, and that means we're going to do what? We're going to multiply by 4 and divide by 5, and divide by pi. So 3.696 times 4 divided by pi, and that's going to give us 4.706. All right, so that's time 1 and time 2. Understand here though, those are the 2 times on the first rotation. But we've got 3 of them. Now it becomes easy, because when we know the first one, all we have to do is add 8 and add 8, because it's going to happen at the exact same time plus 8 minutes each time. Same thing with this one. So what happens is, this kind of may throw you off, but understand they're using the trig function and all this, and at the first one, we're going to be right here. At 3.294, they're going to be right there, and that's where the height is 40. And then they're going to rotate on up to 43, and then they're going to come back down to 40 right here, and that's going to be at time 4.706. And then what's going to happen? Well, from here it's going to be 8 minutes, and they're going to be back around at this. And then they're going to be back around at that one again for the third rotation. And the same thing's going to happen here, plus 8, plus 8. So now we just take this one, and we're going to add 8, and then we're going to add 8 again to get 2 other points, 2 other times, sorry. And we're going to do the same thing over here, plus 8 and plus 8, and get the other 2 times over there. So 3.294, let me change colors here so this doesn't all, plus the 8 is going to give you 11.294, and then plus 8 again is going to give you 19.294. So at 3.294, 11.294, and at 19.294, they're going to hit this location right here. And then at 4.706 and at 12.706, I added the 8 to it, and 8 more is going to give me at 20.706. At those 3 points right there, it's going to be hitting at this point right here. It's going to hit it the first time at 4.706, and then 8 minutes later it's going to complete a whole cycle and get right back to that exact same point. So those are all the times that it's going to be at exactly 40 feet above the ground. So you could list all those out in order, would probably be best. So 3.294 and 4.706 and 11.294 and 12.706 and 19.294 and 20.706. 1, 2, 3, 4, 5, 6. There we go. There's your answers for all those problems. All the different times that Patty is going to be exactly 40 feet above the ground.